Okay, today we're going to be talking about trigonometric identities. And first of all, we're just going to go through these, the fundamental ones, and some of these are you're familiar with already, are the reciprocal identities. We've talked about these. The quotient identities, where tangent x is defined by the sine of x over cosine, and cotangent is the cosine over the sine of x. Pythagorean identities, we really do a lot with these when we're solving or verifying trig identities. So sine squared plus cosine squared equals 1. Now, we can also solve this for sine squared. Let me just make a note of that. So in particular for this one, if I have sine squared x plus cosine squared x equals 1, and I want to solve that for just sine squared, so I want to get this by itself. What will we do to do that? Subtract cosine squared x from both sides. Whatever you do to one side, do to the other. And that would give us sine squared x is equal to 1 minus cosine squared x. And the reason why I show you this is because we'll use this tactic often to solve for one particular trig function versus the other. So this is equivalent to this identity. And the same thing can be done for this. I can solve for tangent squared x by subtracting 1 from both sides, so on and so forth. So we will do that often as needed. So that's something that we'll have in mind. The other thing that we have mentioned before are the even-odd identities. Sine of a negative x is equal to the negative sine of x. And that's similar for its reciprocal identity. The only ones that are different for the even and odd that you really need to focus on remembering are going to be these two right here, because cosine of a negative x is equal to the positive cosine of x. So this is our even functions right here. So then secant, which is its reciprocal identity up here, likewise. Okay, so really have to zone in on that one to pay attention when we work these. But this is just a basic recall information of your fundamental trig identities, and you should have a handout with those on it. So to just have some guidelines for verifying, we'll work with each side of the equation independently. And typically we like to start with the more complicated side. So when we have these identities, we'll start with the more complicated side and basically keep working with our identities, and then we'll try to make it look like the other side. Another thing, we look for opportunities to apply the fundamental identities, which, recall, these are our fundamental identities here. Okay. Try one more of the following techniques. So there's different techniques for these, and sometimes it's a matter of trial and error. Okay, the more you do these, the better you are at determining what's the best method or tactic for making this work. So rewrite the more complicated side in terms of sines and cosines. We do that probably most often. Another thing we look for is sometimes we can factor out a GCF. If that doesn't get us what we want, occasionally we will separate a single term quotient into two terms. So basically, right here, I would say, well, A divided by C, that's this, and plus B divided by C is this. So you rewrite it like that, or the same thing with subtraction. Okay, so that's rewriting a single term quotient using two terms. Another thing, combine fractional expressions using the least common denominator. And one of the last techniques is multiply the numerator and denominator by a binomial factor. And last thing is, don't be afraid to stop and just start all over. Okay, so some of this, like I said, we'll try, and if it's not working out, we'll just scratch that and start over and try something else. Okay, so the first example we're going to work with is just a simplify. So we want to try to rewrite these in terms of sine and cosine if possible. So the first one, in the numerator, tangent theta, what can I rewrite as tangent theta? If you look back to your previous page, your tangent theta is going to be your sine over your cosine right here. So tangent theta I'll do in blue, so that's sine of theta over cosine of theta. And how can I rewrite secant theta? Using the reciprocal identity, 1 over cosine of theta, right? Okay, so now if I want to simplify this, I can multiply the bottom by the reciprocal, which would be times cosine of theta over 1. Whatever you do to the denominator, make sure you do to the numerator as well, so cosine of theta over 1. Now, what happens down here? Nicely, everything's going to simplify, so this simplifies with that. And then what about in the numerator? These cosines simplify. We're just going to be left with, in the numerator we have sine of theta over 1. In the denominator we just have a 1. So this entire thing just simplifies to the sine of theta. Okay, so our next one says we want to show that sine of theta over 1 plus the cosine of theta is equal to 1 minus the cosine of theta over the sine of theta. So we're going to choose one side to work with, and we're going to try to make it match the other side. So let's work with the left side. So I'm going to pull this side down first of all. So let's just work with our left hand side. So I'll say sine of theta equals 1 plus the cosine of theta. Okay, so let's think of some of the things we can do. Rewrite in terms of sine and cosine, that doesn't really help us much. Let's see. And this is part of this process, and I want you to see this as in thinking through this. We'll look through some of these are just some things to try. We'll also have some other, a GCF. They don't have a GCF in our problem. Combine fractional expressions using the least common denominator, or multiply numerator and denominator by a binomial factor. So when I'm looking through this, a lot of those don't necessarily apply in this one. So the first thing I'm going to try to do is multiply by the conjugate, which this is a tactic we can use often. So if I have 1 minus the cosine of theta, then I'm going to remind you. Okay, so recall from algebra the conjugate. So what would be the conjugate of 7 plus 5i? Just 7 minus 5i. Right, so in this case, although this has a trig function, 1 plus cosine theta, the conjugate is 1 minus cosine theta. So this is another thing that we'll use. Now, why would I just out of the blue try a conjugate? Well, I did notice that on my right hand side, you got to keep in mind where you're going. And like I said, some of this up front is just learning some of the tactics, and it's not very obvious initially. But I noticed on the right hand side, I'm trying to get to here, and I noticed that it's the conjugate. So if I multiply the bottom by that, what do we have to do to the numerator as well? Multiply by the same thing. So whatever you do to the numerator or denominator, you must do to the numerator as well. Now let's go ahead and simplify this part. Okay, so distribute that out. That would give us what? Sine of theta, then minus sine of theta cosine of theta. Okay, now in the denominator, we have to FOIL this, right? It's a binomial times a binomial. So let's do FOIL. I'll do this in blue. So what's 1 times 1? 1. What's 1 minus cosine theta is negative cosine theta. Good. Now let's go here. Cosine theta times 1 is positive cosine theta. And then what is a positive cosine theta times a negative cosine theta is going to be a negative cosine squared theta. Okay, so that step we just simplified. All right, next thing we want to do these two terms in the top have anything in common? A sine theta. So let's factor out a GCF of a sine theta in the numerator. So I'll say if I pull a sine theta out, if I divide this term by sine theta, I just have 1 as a placeholder. What if I divide a sine theta out of this? What are we left with? A cosine theta. Okay, and then in the bottom, in the denominator, cosine, a negative one and a positive one cancels out, and we will just be left with our 1 minus cosine squared theta. Okay, what do we think about this in respect to our Pythagorean identities when we solved that a minute ago? Remember when I just took that one for example and solved for sine squared theta, it would be 1 minus cosine squared theta. So in this case, I'm going to use that identity and replace. So I'm going to leave my numerator alone. In my denominator, I'm going to replace 1 minus cosine squared theta with sine squared theta. So this is what I'm replacing. I'll put it in blue. Now, what can we do with a sine and a sine squared? I can reduce by a sine squared, right? So I will just have 1 minus cosine theta in the numerator, and I'll have 1 sine theta in the denominator. And is that what we were trying to get? Yes. So we were trying to get 1 minus cosine theta over sine of theta, and we achieved that. So check.